Hello everybody. I am happy to be making this response video to my initial prompt. My question was that if I have this curve, this graph, and all the x values represents the number of items, and the y values associated with it represents the cost. Okay, so like for example, this point here says, there's no more information to know exactly what's going on, but it says like 4 items is associated with the cost of $250. Okay, that's what that means. Anyway, so I said, can you calculate the average rate of change between the points A and B? And round if needed. Sometimes we need to round. But most importantly, I would like to see if you can give me the units for the rate of change, if there are any. So I posed it in my initial prompt, like maybe there are units, maybe there are not, maybe it's just a number. 250 is a number. $250 is a number that has units, okay? Now it would be very important in our class to keep track of the units of just about anything we're dealing with, whether it's money, whether it's production, whatever it happens to be. So the average rate of change formula is right here, and it's basically the slope formula. I mean, that's all it is. I mean, you could see this as the slope formula that you've probably seen before, y2 minus y1, y2 minus y1 over x2 minus x1. Okay, so that's what it is. All right. But we do have units associated with those numbers. So I wouldn't just think of it as, okay, the average rate of change, since it's basically the slope formula, is, let's see, 350 minus 250. To be looking at it that way would be too short-sighted and it would be incomplete. Because what's 350? It's $350. What's 250? It's got units with it, $250. So notice how I included the numbers and the units. So that's what you get on top. Now, $350 minus $250 is $100. So notice I'm preserving the units through my calculation. And then on the bottom there, x2 minus x1. I don't take 9 minus 4 as if those are just numbers with no meaning or context to them. It was 9 items. Okay, there's something that's for sale or something, who knows, doesn't say, but 9 items minus not 4 but 4 items. So notice how I preserve the units through my calculation. Now if you have 9 items and you take away 4 items, you get 5 items. See how the units are preserved there? So I get $100 per 5 items. And one way to look at that number is, well, on this curve, if you were to increase the number of items by 5, the effect of that would be to increase the cost by 100. That's how we can look at this number. $100 per 5 items to get from point A to point B. Must have a grasp of the units and must keep track of the units. Now, normally when we have a rate of change like this, we divide it out. We just say, well, the 100 and the 5, that makes 20. So it would be accurate to say $20 per item. Okay? All right, so those are the units. That's how we understand the units. And if you can walk away from this thinking, well, we just use the slope formula to find the average rate of change, but with the numbers involved, we keep whatever units are given with those numbers in the first place, and then we have the units and we have the answer, and that's the total answer.